Okay, so there are two rules that I don't know if you guys have learned yet in your course, but I just want to quickly show you a preview of it. And that those rules are the product and the quotient rule. So the way that the product rule works says that if you have the derivative, if you're trying to find the derivative with respect to x of one function, call it f, times a second function g, then you can write out your derivative as g times f prime plus f times g prime. A way to remember this is as follows. You can say low d high, high d low. Low d high plus high d low. Halloween's coming up. Try to mimic that with Chucky's voice, and you'll be fine. You'll be fine. So this is extremely helpful, by the way, when you get to the quotient rule, because the quotient rule says that you have f divided by g, then this is simply equal to g times f prime of x minus f times g prime of x, right? So low d high, right? Low, which is your g, times the derivative of the high, f, minus the high, which is your f, times the derivative of the low, which is g, all divided by g squared. So in short, just remember, low d high, high d low. Let me show you two examples, right? I'm going to introduce how to find these derivatives, and then maybe next week we can do some more examples. So here's my example one. Let's say if I have the, the function h of x equals x to the fourth power times ln of x. If I want to find my h prime of x, I first recognize that since I have a product of two functions, I need to apply the product rule. And when I apply the product rule, what I like to do is do some scrap. I like to write out what's my f, and I like to write out what's my g. So usually in the product rule, f is the first function, x to the fourth, and ln of x is your g. That's your second function. Now, underneath these two functions, f and g, I like to write out my derivatives, f prime of x and g prime of x. So, what is f of x? F of x is x to the fourth. What is my derivative? Careful, not 4x. 4x to the power of 3, right? Or 4x cubed, right? By the power rule, their derivative is 4x cubed. Now, what is your derivative of ln of x? 1 over x. Now, how is my scrap work helpful here? If you just remember that you write out your f and g's, and right underneath you write out your derivatives, you can essentially create the Jamaican flag. Anybody knows how the Jamaican flag looks like the x? Has an x on it? So it's like you're taking x to the fourth, or f of x times g prime, and then you take f of prime of x and you multiply it by g. Okay? So when you apply this, we say that h prime of x is equal to, if you want, g of x times f prime of x. So you can write it as 4x to the third times ln of x plus x to the fourth times 1 over x, right? Just remember, you have your f and g, right underneath, you have your derivatives, and it's like you're doing a cross multiplication. You're sort of creating this Jamaican flag. And now you just simplify whatever you need to simplify here. So we have 4x to the third of ln of x plus x to the fourth times 1 over x. So what is x to the fourth over x? If you simplify it. X to the power of 3. Very good. So that's our derivative. That is essentially how we apply the product rule. Any questions? Any questions? No? Okay. Let me show you one more example, and this time I'm going to use the quotient rule. So the quotient rule, example 2, says that I want to find let's say my function, I call it k of x is equal to tan of x. Now, I wrote this on the board earlier while I was pausing the videos. I said that the derivative of tan of x our derivative of tan of x is secant squared of x. But I did say earlier that I want to prove this using the quotient rule. The only way that you can prove this using the quotient rule is by rewriting tan of x using the quotient identity from trigonometry. So do anybody remember what tan of x looks like as a quotient? I'll give you a hint. It's something over something.
Sine over sine,
Sine over cosine. Very good. Oh, no. I think you were probably thinking about reciprocal. Yeah, that's okay. No worries. So k of x, which is equal to tan of x, can be first rewritten as sine of x over cosine of x. This is what we call the quotient identity from trig. So now that I have k of x is now equivalent to sine of x over cosine of x, if I want to find the derivative of tan of x, it's equivalent to finding the derivative of sine of x over cosine of x by the quotient rule. Right? So k prime of x is equal to your derivative with respect to x of sine of x over cosine of x. And remember the saying. What was the saying? There you go. Low D high. High D low. All right. So the low is cosine of x. Now, the D high is the derivative of sine of x. What is our derivative of sine? Nope. Just cosine of x. All right. Minus, so in between the low D high, you have this minus sign. Minus high D low. So you keep the high, which is sine of x. And now you take the derivative of cosine of x. What is the derivative of cosine of x? Say it louder. Negative sine of x. Just remember now that in this denominator, it's going to be the denominator squared. So it's cosine squared of x. All right, let's clean up the algebra regarding this derivative. Well, what's cosine of x times cosine of x? Cosine squared x. Very good. So the first part will become cosine squared of x. Then you have negative sine of x times negative sine of x. So what happens to your two negatives? Say it louder. It becomes positive. The sine of x times itself is sine squared x. And this is all being divided by cosine squared of x. Now the idea here is that when you look at this numerator, cosine squared of x plus sine squared of x is equal to a single number. Do anybody know what that number is? That is equal to 1. Very good, Ricardi. So this piece here is equal to 1 because it's the Pythagoras identity. So I'm just going to abbreviate that as we're running out of time. So the Pythagorean identity says that if you have cosine squared plus sine squared, it's always equal to 1. Okay, so now we have 1 over cosine squared of x. Well, let's just assume I pull the square out, right? I could pull the square out from the bottom, and I could pull the square out from 1 because 1 raised to any power technically is still 1. So when I look at this expression, 1 over cosine of x, you now can use what we call the reciprocal identity. Anybody remember what's 1 over cosine? Somebody saying it? Secant. There you go. You were saying it. You had this part, but I'll try to help you finish it. So it's secant of x, or now secant squared of x. And if you look at what we begin with earlier, did we said or establish earlier that the derivative of tan of x is going to be secant squared of x? Yes or no?
Yes.
Yeah. It's right here. And by the quotient rule, I was able to prove it. I hope you enjoyed it. All right, so